Hi, everyone, and welcome to our webinar, Don't Sweat the Small Bugs, Speeding Up Pipelines Using Risk-Based Security Decisions. My name is Raquel Soares, and I'm the head of marketing here at Uleska. And for those of you that don't know, Uleska is a platform that helps you scale application security by fully automating and orchestrating your preferred security tools in CI/CD. I'm super excited to be here today. I'm also really excited to have Gary Robinson with us today. Hi, Gary.
Hi, Raquel.
So tell us a little bit about yourself, Gary.
Thanks. So yeah, excited to be here as well. Looking forward to this session. My name is Guy Robinson. I'm the founder and CEO of Uleska. My background includes 20 years experience in software and cybersecurity. I've been a board member at OWASP. I've been a security architect over at Citigroup, a pen tester, a security consultant. And at Uleska, we've been focusing in on the automation and the risk of software security tools and CI/CD. So I'm really looking forward to this session, Raquel.
Awesome. I'm also excited. I can see we have a lot of people joining this session. So what are we going to cover today? Gary, if you can switch to the next slide. Yes. So essentially, we will be talking about speeding up pipelines using risk-based security decisions. And some of the areas that we will cover, because obviously this is a big topic, but we will be looking at some of the challenges that most people face today, why you should be automating security testing, how you should be thinking about risk, and how we do it at Uleska, and some final takeaways so for you to get started with your own programs. So yeah, Gary, please tell us about some of these challenges that you have seen in the industry today.
Thanks, Raquel. Yeah, so software development's at a phase right now where Agile and DevOps, etc., is allowing the businesses to be able to produce software and releases and value to themselves and their clients at a much greater pace than before. And this is great for businesses because you can get the releases out there, you can see the changes, you can get the updates, but security is typically being left behind and is needing to come into that way of working. So this is producing a number of drivers and challenges for everybody in the security industry. So a number of challenges there include things like the regulations. You know, you've got the New York CRR 500 or BaFin in Germany, etc., and many others that are enforcing both timely verification of security in software. So essentially being able to check the security before you release, and the ability to have those risk-based approaches. So we'll discuss a lot more about that later on, but how do we make sure we understand the impacts of these changes and these problems instead of just the vulnerabilities? And there's lots of other clients that are looking for this information as well. So if you're a software company that provides software to your clients, you're essentially part of the supply chain, and those clients are going to want to understand their supply chain risk through understanding the software and the updates that you're providing them. But also, if you're your own company, if you're a mid-tier or enterprise company and you have security stakeholders, they're going to be looking for this information, both from the security and the risk point of view. And what this results in is our heroes in development and security and DevOps who have brought around this fast-paced software development. It's given a challenge to them, and people call it, shift left or secure by design, DevSecOps, or security as a service, as we hear. And that's typically requiring the ability to have those automated security checks in their software development lifecycle, be that manual waterfall processes, CI/CD, whatever it is they're using, so that the security can keep pace and have measures of the verification of the software before it goes live and out to customers. And we have to remember at the bottom here, the most important aspect is that we're not doing security automation for automation's sake, because that kind of doesn't make sense. The question we're actually answering here is, between release and release, what has changed in terms of our security profile and the risk that causes to the release we're about to do. That's really important for us to understand, the software development teams and security teams, but also our clients as well.
Yeah, that's really good to know, because I'm yet to find a person that loves to do manual work. So why should you be thinking about automating security testing today, Gary?
You're very right, Raquel, absolutely. So Today, security is driven by standards, it's driven by regulations. We have, if you're a large enterprise, as I've worked in before, you're going to have lots of security documents that will list lots of technical or procedural controls that a security review or check should be checking for. Or even if you're in another organization that doesn't have those standards, you've still got systems like NIST or OWASP, like the OWASP Top 10, or the ASVS, which is the Application Security Verification Standard. And something like that lists around 300 controls, technical controls, like maybe one would be checking for SQL injections. Another one might be, command injections or some sort of authorization or authentication check, etc. And really, what we're doing when we say we want to secure something is it's verification against controls like that. And if we're taking something like a approach to security where we take our favorite tool, security tool, and we stick that API into our CI/CD, it's kind of a bit of a blind approach because we probably don't know what that security tool is actually checking for. Of the 300 controls we mentioned there in ASVS, does it cover all 300? Does it cover 5? What security does it apply to us? And that's something we want to keep in mind whenever we're building a security program and bringing this out. So we have done some research around things like NIST and ASVS and comparing that with the various types of security tools that you can be putting into your CI/CD automation program. And the joined up approach is taking some of those controls, as I mentioned again, the 300 that would come out of something like OWASP ASVS, and knowing of the tools we want to put in and the verification we want to happen, what are these tools actually doing for us? What's our ROI in terms of this effort of putting in that automation? So taking something like a popular open source tool like Bandit here for the Python language, analyzing that gives you about 16 controls, or around about 7% of OWASP SVS if you stick Bandit in to check your source code for that. Taking something like SonarQube, which is a really popular commercial and freemium tool, it covers up to about 13% of the source code checks you would have. If we take a dynamic check, something like a WhatsApp or Burp Suite, that could be something like 19, 20% again of the overall controls if it found everything that it could do during its dynamic checks. And as you see then towards the right-hand side, what we're saying is if you take a combination of these tools, you start raising up the scope of the checks you're able to do. So taking something like Bandit, Node.js Scan, SAP, OWASP Check, and SonarQube, etc. You can then build up a Venn diagram overlap of controls, which then gives you a bit more coverage, up to about 36, 37% of the controls you might want to have. Now, that will differ depending on the tech stack of the various projects you're working on, etc., depending on the tools you have. But also one thing to keep in mind here is that off-the-shelf tools, like commercial tools and open source tools, some of them have very good coverage, but you tend not to get very high coverage because there's not because of the issue with the tools, it's because the nature of the controls from ASVS or others will be quite specific to your product. Something like a business logic check or something specific to, say, authorization or authentication that wouldn't be discoverable by any off-the-shelf tool, no matter the quality of it. So when you're building your automation program, you have to remember that you're likely going to need a number of security tools to give you adequate coverage. Otherwise, you're just running a tool, hoping to find everything and understanding your security from that. But you also got to understand you're going to be bringing in the nature of custom tools as well. And we see this in lots of different organizations where somebody from development or security or the ops team has created, a 20-line Python script or something that does a check, an automated verification that's quite important to that organization. One of the challenges there is how do I productize and make that part of my security automation profile? So we'll look here at some of the challenges then that this groupings of automated security tools brings into an organization, because again, you can take one tool and for technical people, taking the API of that security tool, hooking that into our CI/CD, bringing the results back, and then deciding to do something inside CI/CD based on the results. That's that's doable. That's a project you can create, and we see many people doing that. However, there's a lot of work to do that to again interact with the APIs. It's not just as simple to do, and also to interpret the outputs and make decisions there based on critical or high or whatever those sort of things might be. That's a bit of work. And when you start bringing in more and more tools to get more coverage and bring in your custom checks, and then also check different types of thing like source code, software composition analysis, containers, your dynamic checks, your infrastructure and cloud checks, suddenly it becomes a number of different checks you're having to do during your CI/CD cycle. And if you imagine in the background here, the types of codes or scripting you're going to have to create just to have these API interactions is going to be quite numerous. And if you take organizations that have hundreds of projects, this becomes completely unmanageable. And still at this stage, we're still doing we're still doing automation for automation's sake, because we're kicking off a bunch of tools. We're able to find hopefully find a number of security issues, but nobody in your development teams or your security teams is going to thank you to have to look at 15 different security tools or whatever it is every time they do a build to try and determine if any new security issues have come up. That's something that's fairly unmanageable when you're running fast-paced builds that go out every hour or every day or even every week. And on top of just the pure technical plumbing, you're going to have to understand certain things across all these tools. You're going to have an infrastructure to interact with these APIs, maybe to spin up open source tools that run a command line, and something to track the profiles is going to be run for each of those. And you're going to have to, again, try and build that into where is it in your CI/CD? Is it being run something else? What sort of platform or product are you building here? You're going to have to understand that every tool outputs its vulnerabilities in fairly different ways. There is no standardization in the industry. So how do you get towards something like a single pane of glass for all your various security issues, no matter what tooling you want to put in and put out here? Because that's going to differ for different tech stacks as well. Lots of the organizations we work with have different teams working in different source codes, building different types of products, working in different frameworks. And so the tooling that you actually want to run here gets quite segregated. And you want your security program to be quite consistent. You want your tools to work around your security program, not the other way around, because that just can't be kept up with. And as we mentioned before, the main question you're trying to answer here is what has changed from the previous time we ran these tools through our code line. We've made some code changes, we've brought in some new libraries. What is the change that has come about across all these tools? Do we have 2, 3 brand new issues? How do we understand those quite quickly, and how do we understand the risk of those? Because there's always a security backlog. We see some other efforts and programs around this area to work with lots of different tools that can hook together lots of tools into one place. Typically try to run with a mindset that if there's any security vulnerability returned, that's going to break the build. And we don't see any organization for which that works, because, as I say, there's always a security backlog, just like there's a bug backlog and other backlogs in any software development organization. So part of the challenge here is how across these different builds, across all projects and across all the different tools, can we easily and quickly in real time understand what our backlog was before, what it is now, what's changed, and more importantly, what's the risk of that, so that we can make automated risk-based decisions before going to release our software into the wild. Because it's only when you release the software that those vulnerabilities actually become real.
That's really interesting, Gary, because obviously we started talking about the need to move away from manual to automating. But then to your point, okay, automating doesn't just solve the problem, because you may get a bunch of things to do without knowing how to prioritize. And therefore, it's really important to look at risk and how to think about risk and approach risk. So tell us a little bit how you think about it.
No, that's right, Raquel. Yeah. So risk is really interesting to talk about risk as versus vulnerabilities, and everybody's probably seen this sort of diagram on the social media before, and we've put it in here because we love it. It's just nice to explain, and it shows quite well the conceptual difference between what is a vulnerability and what is a risk, because a vulnerability is pretty much static. It is a vulnerability in terms of the technical problem that it is, but the risk that represents the different types of products can really differ. And The example we typically use is something like an SQL injection, which is a vulnerability quite common, been around for a number of years. And most of the tools that you would run that would report that back will probably flag it as a high level issue that is important. But if we take two examples of projects that each have SQL injections, let's take one SQL injection on a internal project that has no sensitive data, no real users, something that the internal cleaners use to decide which room they're going to clean on a Thursday or whatever. So even though it's an SQL injection, that is not a problem, a risk that is actually going to cause any real impact to our business. We're not going to be on the front page of the newspapers, or we're not going to lose millions in terms of fines because of that risk being exploited. And the chances of that being exploited are quite low because it's internal and only a few users. But if you take exactly the same vulnerability and take it in an external project, which is got millions of passports and financial data and is vulnerable to an SQL injection, well, then you've got something like the TalkTalk hack, which happened a number of years ago and resulted in bad impact and lots of different fines, etc. So the same technical vulnerability, but the impact of that really depends around the project, the criticality, and the data that's being used. And that's an extreme example, but it's a way of making sure we understand just because the tool returned a high, there's actually other ways we can think about the overall impact of that to our business. So there's different risk frameworks that can be used, Octave or 27005 from ISO, etc. We have lent towards the FAIR Institute framework, which really lends itself towards an AppSec type of world and basically putting risk values against those technical flaws. And to talk about how we do this here, we've just drawn this bit of a graph. So from the bottom working up, if you take the technical vulnerability that comes back from a lot of these tools with the high, medium, lows and the CVSS scores, etc., that lets you understand what technically that vulnerability is going to be. How does it get impacted? Who can typically be able to breach that sort of vulnerability? What's the confidentiality, integrity, or availability impact of the bug? And if you take that and then combine it with more context around the application, so as I mentioned, how many users are in this system? How many, what's the cost of a downtime? Is this system critical to us as a business, or is it a side project that we don't really worry about? And if we also combine that and wrap it around the types of data being used inside this project, does it have lots of PII, financial information, healthcare information, etc., like that? That then gives you a lot more context of the impact and likelihood of this vulnerability being exploited. And that's exactly how the FAIR framework algorithms work. And what we've done in Uleska is actually implemented that FAIR framework algorithm inside our product so that whenever any of the tools we run bring us back vulnerabilities, they automatically run through that algorithm to be able to produce an impact score, a risk score as well. And this helps you understand then across your projects and across your various vulnerabilities, what is the risk of those various things being worked on. It helps you prioritize and also helps you measure what's going to go forward.
Okay, that's a lot of theory. So it'd be good to know how it looks like in practice and how we think about these things at Uleska.
Yeah, show not tell, absolutely. So at Uleska, what we do is we take people's normal CI/CD pipelines, and the way we approach it is we bring along beside that what we call a security pipeline. And this is a consistent pipeline that does the tasks which are usually performed by manual people, either in the security team or more often as people are trying to shift left in the development teams. But as we've already seen with development, with automation and everywhere and everything being automated, if you have any manual tasks there in the security department, that's going to slow things down and just blow the time frames. You can't keep up with the speed or the scale whenever you bring in those manual tasks. So what the Uleska system does is it takes the task of, say, running security tests. So whether it's static, software composition analysis, container, dynamic, etc., we can kick off those tools and bring the results back into one place. So you get that single pane of glass and the understanding of what's changed. We do a bit of auto triage. So if you've already marked something as a false positive or a duplicate across all the various tools you've run, that gives you a single place to do that and move them away because they're not part of your security backlog. And as we've already mentioned, we can run them through the Fair Institute algorithm to be able to prioritize those and know which ones are major problems and which ones are not. And the fact you're doing this then effectively in real time along with your CI/CD pipeline means that you can get the results back into your CI/CD pipeline or give them the ticketing systems, etc., but be able to make automated decisions, as we'll show in a second, based on the risk of the new vulnerabilities that are found. And one of the other beauties of this is the process stays consistent. Your test through to prioritize and communicate is a linear way of doing security. Now, the testing tools, which we call a toolkit, may differ for different projects, using different languages, working in different ways, but it's a consistent way of having that security wrapped into your CI/CD and brought back into it whenever you want to do your releases. And doing that across all your various projects means we capture all the metrics. We get to tie them to ASVS categories as we do. We get to see the results changing week by week. And that helps you inform not just your customers and your stakeholders about the current state of your vulnerability and risks, but also lets you see trends and inform your own processes. So before we show a demo of the product, we're going to focus on how the risk can work in the pipeline, because as we've already mentioned, Uleska takes the tools, it automates them, collects all the results together in real time, and does the triage and prioritization. From your risk pipeline then, there'll be different ways you might want to make a go, no-go decision or an intervention based on the risk. So, for example, in our CI/CD, we'll get back, say, all the issues or just the brand new issues. And we can say, based on our thresholds that we've decided earlier, do we want to block the build or make an intervention based on new issues appearing in the system that are over a certain risk threshold per issue? Or we could do it as an overall level. So for this stage, for our SAS testing, our SCA testing, has the risk increased by X amount or X%? We can make an intervention there. Or one of the nice things, because Uleska is again bringing everything together, from your SAS testing through to dynamic, through to your cloud testing, etc., is you can look at the risk for the overall project at the end, just before you release, and say, across all of our different testing tools, has the risk gone to a certain threshold that we want to make an intervention or have a look here, or do we want to look at any of the stages? So this lets you really have a lot of control from your CI/CD point of view over how risk is going to affect the way your builds go. So what I'll do now is I'll just bounce off to show a bit of a demo of our platform and how this works going forward. So hopefully you see my screen. This is the UI of the Uleska platform. It's a standard enough application security interface where we got different projects going through. Now, what we're going to concentrate here is our unsafe bank application, which we've already set up and having a couple of test runs running through. Now you'll see here we've got rows for different stages that we're running currently. One for software composition analysis, we've got our SAST, our DAST, our container, etc. And when we say we've got these various different stages, what we actually mean is we've built up a toolkit of various tools that make sense for this project and that stage. And this toolkit then says anytime somebody goes to our system and says test now, which you can do manually, or somebody connects to us over an API or uses our command line interface in their CI/CD, that means that tool set of tools with the profiles and configuration they have is going to run automatically during the CI/CD build or whatever that may be. And it will return the results back to the Uleska system. Now, the Uleska system will already have a backlog of those results recorded. So this essentially becomes our security backlog. These are issues that existed in the system during the last build or the last scan. Now, you can take some of these issues, you can mark them as duplicates or false positives, so they go in the back. You can also see older reports and older runs that existed there. But as you'll see here, we automatically prioritize the issues as they come through. And that's both to allow you to measure the risk across issue, lots of different projects, your whole organization, etc., but also prioritize. If I'm a software developer or if I'm a project manager and I have this as my security backlog, I know I'm going to start working on these ones first before I work on the lower risk ones, because that's the biggest risk to our organization if we release this software. So what I will do is I will go back to our application. Now, if I go to, what I want to do now is show you how this runs in CI/CD. So if I take our Azure pipeline here, which we did before, this is a YAML file for a demo system we have set up. And what we have is this YAML is going to go through and it's going to, create our deployments. It's going to build our system, run our unit tests. And if we get down to here, essentially this is where the Uleska command line interface interacts with the CI/CD and allows it to call the Uleska system over our API. Now, in this example, I've left it quite raw because I want to be able to show it, but you can obviously build this into templates and make it a lot cleaner. But essentially, our Uleska automate script, which you can get from pip, reaches out to the Uleska system you have with the application you have and tells it to run the particular type of testing we want it to run. So we've got SEA testing there, our SAS testing there, which will map up to the various toolkits we have specified here. Now, it can run in a couple of different ways. In this scenario, we have it running in what we call blocking mode, which is test and compare. So it's going to invoke those various tests. It's going to wait for them to run. It's going to get the results back. And then it's going to compare the current security backlog with the previous one and highlight any brand new issues and also the risk with those. And in this case, if those new issues are over, or any particular issues over 300 risk, or sorry, 300,000 risk, or if the overall changes is over 700K, then it can make the decision to have an intervention in the build process, for example, fail a build. Now, this can also work in what we call non-blocking mode. So it can kick off the testing, let the rest of the CI/CD run, and then it can come back later on and do the compare then to see what the results are. That really comes down to how you want to run it, what the length of time you have in terms of testing tools. Some tools are quicker than others, and also how many tools you have running in the system. So we have a number of different hooks down here in our CI/CD. So if I go down here, will be a few more for our DAS testing and cloud testing, etc. But I'm going to go through a previous run of this just to save time, to save us going through the build process, and show how this both allowed smaller bugs to go through and keep on running with the build, but then block in our SAS version because that's where the threshold was blowing. So if I just go to our previous build, what we can see here in Azure DevOps is we've ran through our various processes, and when we got to here, we got to the point where the Uleska platform waited for the testing to finish. It showed us our latest report, it showed us our previous report, and it highlighted the differences between the two. So it's showing you the increase in risk and the percentage increase in numbers of issues, etc. But it also shows you here quite nicely the various issues that were raised, what tool raised it, risk and CVSS scores, etc. like that. Now, those issues could also be replicated in our system and also in your Jira or ServiceNow, etc., whatever it is you're using. But because this particular one didn't have issues that were over our threshold, as we determined, the build was successful and moved on. If we go down to our SAS testing, this time we had more issues, and we also had a bit of higher issues. And in this case, as we see here, it failed the build and had an intervention because there was issues that were over a certain risk threshold. So that was 300,000, and we had an issue that was over a certain size. So that's just an example of how this would run. Obviously, the risk determinations, the thresholds, how you want to do that is up to yourself. But if we take a step back and think about what happened here, without manual intervention, bar the setup, whenever somebody else ran their CI/CD build, the testing was run automatically, the toolkit was brought together and run, the issues were collected together, the triage reoccurred, the backlog was compared to the previous, and the risk was reapplied to let us understand what those changes were. So this allows you both to understand what the risk is for your overnight or for your project, but also in real time catch those big issues, have a look at them, and decide what you're going to do before you go to release. So if we go back to your Uleska system here, that again is replicated here in our overall risk, etc. But just to show that the Uleska system allows you to take analytics of all of this going ahead, because if you take the various builds and projects you're working on and map them into previous weeks, We can show over time how much the risk is going up or down, how much your vulnerabilities are going up and down, and your number of projects. But it allows you to understand, are our projects moving up or down in terms of their addressing of risk? How does that compare to vulnerabilities? So for example, in this particular demo system, between week 29 and week 30, we had a massive drop in risk. But if we look at the vulnerabilities between week 29 and 30, the number of vulnerabilities was actually only about 8 that changed. But that shows that the 8 issues that we took away at that point were the highest risk issues that allowed the risk to really drop. So this is all about helping you focus the development teams on new issues and on making sure the security backlog is burnt down in the right way. And overall for your organization, again, because we're tracking all these different issues across projects and mapping them to ASVS categories, you can look at the various areas that are coming up and have ideas on, well, where's most of our risk coming from? What can we do to address that? Do we need to bring in some training courses? Do we want to do a few brown bag sessions? Do we want to bring in some libraries, etc., to help us with those sort of things? So it helps you do some joined up thinking in terms of your security programs. And if you want to bring it down into individual projects, this sometimes takes a wee bit of load, but you can actually see the statistics for your individual teams and understand not so much the game, but do some teams doing better than others, or some teams working on the more risky stuff, etc. We can see the Belfast and the Amsterdam team here in the last week have had an uptick in terms of the risks they have in their projects. We can compare average risks. We can look at the individual teams and see where their risk values are looking. So it just helps you to see where the various projects are, because all of that information is coming through the centralized Uleska platform. And again, for you to build all of this automation, bringing the information together, the triage and the backlogs, the risk, the metrics, and try to put that into your own CI/CD, that's a large, massive project that's really, really hard to get going. So the Uleska platform allows you to get that going a lot quicker and make that sort of life a bit simpler. So we'll go back to the slides now and move on to the takeaways.
Yeah, so first of all, thank you for sharing that. That's a lot to take in. And just so you know, we are recording the session and we will be distributing with everyone that signed up. So you can definitely go back and rewind some sections that you want to probably have another look at. But yeah, I think one of the takeaways for me is that it's all about focus and be able to prioritize the right things so that we can move more efficiently. But obviously, Gary prepared a few more takeaways for you. So tell us, Gary.
Sure, no problem. So this is all about taking away those manual tasks, taking away the friction that helps people to get the speed and scale into this. And we find a lot of organizations are not sure where to start, or they do make a start and they run into problems. So the Uleska system, both our platform and our services where we can advise on these sort of things, are here to get you up and started quickly and easily. Getting those tools wrapped into your existing processes, be that a CI/CD process that you're already working, or if you've other teams that are working with different systems or not even working with CI/CD or DevOps, you can still run this as we showed with the test now button that's on the screen, or you can create your own webhooks. We had an enterprise in the US that hooked in with Slack webhook to be able to start testing from their Slack. So it really depends on what way you want to get this started, but it's taking those tasks that are typically done by the security team or the development team, and which slow the security process down, and getting those wrapped in. So Uleska is here to help you get going with that nice and quick and easily. Using those hooks, again, wherever they may be, in your CI/CD or in other processes, to catch the risks before they become real is really important, both for you and your clients and your stakeholders. This means that the vulnerabilities get spotted quite quickly. That's a really nice model to have with your development teams as well, because there's nothing worse than being a developer, working some piece of code, getting it out the door, and then weeks or months later, having somebody come back and tell you there's an issue, and then you've got to go back through reams of code and maybe some other changes that have happened since. So this is all about making that more efficient, more smoother, and as you say, doing a lot more with less resources, because you get this set up, you're running the tools through, and the development teams are getting to understand the information a lot quicker. Again, without being flooded with information. The backlog's still there, but they're getting highlighted with brand new issues. And that's something, again, Uleska can help with. It's beyond the scope of this particular webinar, but the tools you decide to put into your system, really, that's where you want to be spending your time thinking about it. You don't want to be building this sort of platform for yourselves. You want to be able to understand what is the tools that make sense for our different systems. And that is something we can help because we've understood the tools and the various regulations. But lastly, you can then use Uleska to help with your reporting. You can build PDFs off this. There are organizations we've worked with that have integrated with our APIs to build their own portals and their own charts, etc. Because all of this is API first, is all available. So being able to use that to show the progress for your teams and for your products, both to your internal stakeholders, but also to your clients, means you're really ahead of the game in terms of A, being able to do the automation, but B, being able to show the impact and the risk and how protected they are in the product they're using. And then you can also use it for your own internal continual improvement, addressing if you've got something like Secure Code Warrior, or if you're working with some of the training providers, where do we want to focus our training? What teams are running into which areas, and what can we do to help? And that really helps your overall organization take a heck of a step forward on this journey in the easiest way possible, without having to have a whole project or a whole team build up these type of integrations for you.
Cool. So first of all, thanks a lot, Gary. That's really, really good stuff. Also, we have quite a few questions already coming through, and we will definitely respond them. We have plenty of time for it. But just before we get into questions, and by the way, you can still ask questions if you want to. But I just wanted to say thank you all so much for being here. If you want to learn more about DevSecOps, please visit us at uleska.com. You can create a free account. What can people do with a free account, Gary?
They can do everything. So the product allows you to do all the risk, all the testing tools you need to do. It does limit your testing tools to 100 in a month, but that's plenty for people to get started with and understand how they can get going from 0 to 1 with this sort of security automation.
Cool. And so you can follow us on LinkedIn or Twitter if you want to keep up on the latest features updates or just on all the kinds of insights that we put out and future webinars. And if you want to talk to us directly, send us an email at hello@uleska.com. So on to our questions, which is really exciting. So I have a question from Glenn, and he asks if we should we turn risk around and look at which vulnerabilities create the greatest risk within our organization due to lack of collective knowledge on the vulnerability?
Yeah, so that's absolutely something we see, and that's what some of the charts we have that come up allow you to view, because when I showed there that donut chart that was listing the top 5 issues, that's top 5 issues from risk, not from numbers of issues. And that's really good at helping you understand, because it's easy enough to understand what the highest number of instances of vulnerabilities are, but that doesn't tell you the full story. So understanding that from a risk point of view is very important, but also especially in terms of repos and especially in terms of containers, understanding how those vulnerabilities impact the various projects is also a lot more important. So let's take for example, a container that has, just for example, another SQL injection. Well, those containers are typically used in organizations 2 or 3 or 5 or 10 times. And if you think, right, well, in one container, we've got this vulnerability, that may or may not be the most important thing you're going to fix that week or that month in terms of your container vulnerabilities. But if you understand where that container is used is in both low risk projects, but also very, very high risk projects, that can help you accurately determine the impact that vulnerability that is reused often in different projects is actually having to your organization, and helps you prioritize to get that burnt down as quickly as possible. So Glenn, I think, yeah, that hopefully it answers the question, that it's understanding that donut chart of what is the risk instead of just numbers of issues, but then also where are we seeing that risk, how many times is it coming up, and how do we apply that to the various projects.
Cool. Glenn, if we haven't answered your question yet, just send us another follow-up question. Happy to answer that. So another question we have from Jeff. How do the security tools own quality gates work with rules set in Uleska? So how do the security tools own quality gates work with rules set in Uleska?
Okay, so obviously, the way Uleska works is Uleska builds adapters to work with each individual tool. So essentially what we're doing there in the Uleska platform stroke pipeline is we're building the ability to interact with a tool, be it over an API, or if it's an open source tool or whatever that be. And the profiles of the configurations are really set there, usually passed by configuration, either into the command line tool or over the API to the tool. So so to answer the question directly, you can configure, depending on the various tool, you can configure those profiles and set that up. So for something like Web Inspect, you can specify, here's the profile we want to set. That's already been set in the Web Inspect product. Different tools will have different ways of doing that. But that's exactly something, we have a concept of toolkits, which we're elaborating more on as we develop more through that. And the ability to have certain profiles that match with the type of project. So not just we say, oh, team 1, 3, and 5 develop in C#, for example. So therefore, we're going to use the C# tools, but also being able to replicate those profiles and, try them out, try to improve them, try to work out which profiles producing the best results, because now you can do it more automatically and you can chop and change a lot more easily. Being able to bring those profiles as part of the toolkit is really important. And so that allows you, the Uleska platform through its adapters allows you to play about with those different profiles and those different configurations, so you can see what essentially gives you the best bang for the buck in terms of the information you're going to get back.
Cool. So we have time for one or maybe two questions, depending how long your answer will be to this one. So Anthony asks, if they're not using CI/CD for all projects, so will this work?
So yes, it will, and that's something you need to be very conscious of. There's a couple of good books that we use as reference ourselves. One is the DevSecOps book by Glenn Wilson, and also the Agile Application Security book by Laura Bell et al., if I have that right. But those books talk about the ability to have different, have the flexibility to handle different projects, because we've seen organizations that have 150 plus different types of CI/CD, even different implementations from ADO to Circle to Harness to other ones, etc. So you can't assume everybody's going to the same boat. That's another reason why, as we say, we take Uleska as a separate security pipeline and leave that command line interface as an easy hook into whatever system it is you're using. We showed ADO there, but it's exactly the same for Jenkins or for GitHub or Circle and all those other ones. So being able to do that makes it more flexible, because you can control your security and then let the different teams that are using different tech to be able to hook in as they need be. But also, if you have projects, as I mentioned before, that are not there yet for CI/CD, you can still have the security pipeline there. You can have them run it through the Test Now button we have on the screen, or through our API or a Slack webhook, etc. And the beauty of that is, as those teams then move through your CI/CD maturity into CI/CD or whatever's going to be next, the hooks to Uleska and essentially then to your security profile is exactly the same. So there's no massive shift for a team coming from, Waterfall and the Test Now button into some API into full CI/CD. The security pipeline stays the same. It's just changing the couple of lines of code where they invoke the Uleska platform.
Cool. A final question. And by the way, if we didn't get to answer your question, we will follow up after the session. So we won't leave any questions unanswered. But one final question from Indrich. He asked, what's on your roadmap for the next year? Any interesting features coming up?
Oh, absolutely, absolutely. And actually, you know what? What the even better question is, can how much how much of it can I discuss? Because I didn't get any clearance before we started into this webinar. But so there's a whole world. This sort of world of automation and risk and the DevSecOps types platforms is one that's growing, and there's lots of different areas where people are looking to make more and more savings. So essentially, the reason d'etre of the Uleska platform and Uleska as a company is chipping away at those manual tasks that people have to do, be them security, operations, or development, to get security to work, to get security to be automated, to work at the same velocity as development. And more what we're doing is bringing in more and more of those. So I mentioned the toolkits. There's a lot more we're going to do in terms of toolkits to give more standardization, to allow toolkits to be copied. So say you create a set of tools and profiles that's really good for a certain project, and that would be really good as well for other projects. We want to make that as simple as a click and copy, so that you can then bring that across to other people and really get that good standardization, but strength into your security programs. We're also looking at more tools. We're looking at doing more coverage of more different types of tools. We're going to work more integrated with some of the other platforms like GitHub, ADO, etc. Be really part of that ecosystem, so we can be raising tickets within those things and make that a lot easier as well. And there's also other things we're doing in terms of the vulnerabilities, the false positives, etc. What can we experiment with there to make that life easier? So as you can see, our philosophy is take the biggest time sucks, the biggest roadblocks that organizations are having of streamlining security, and let's work to break those down and benefit everybody, because that can be done as a centralized product from a vendor like Uleska. Having every organization try and solve that problem themselves just doesn't work for the industry. So if you have any ideas, if you want to contact us, if you want to have conversations about some of the things you've seen and see if they match up with what we're talking with clients about, very happy to have that conversation, because we're very open to as much customer discovery and validation as possible.
100%. And also, what I would say is, if you do have feedback on this session, let us know. As I said, hello@uleska.com, or follow us on LinkedIn, or just sign up to a newsletter or a free account at Uleska. And with that, thank you all so much for making time this afternoon to listen to us. I hope you learned plenty of new things, and we'll give you lots of food for thought. And yeah, I see you hopefully next time. Take care, everyone, and thank you, Gary.
Thank you very much, everybody.
Bye.